Hi everyone, my name is Tia, and in this video I will be teaching you quite a few methods to evaluate basic limits. So let's get right into it. The most basic technique to evaluating limits is plugging it in. Consider this problem. We have the limit as x goes to 2 and the function is 5x plus 2 all over 4x squared plus x minus 7. Since x is approaching 2, we can plug in 2 for each x, and our final answer is 12 over 11. But we can't always plug in the value. Consider the problem here. We have the limit as x goes to 3, and the function is x cubed minus 27 all over x minus 3. If we were to plug it in, the denominator would be 0, and the value would be undefined. A strategy we can employ here is synthetic division, which will help us simplify the function. So to do synthetic division, we put 3 in the corner and then list out the coefficients, which are 1, 0, 0, and negative 27. So after doing synthetic division, we know that the whole function simplifies to x squared plus 3x plus 9, and then we can replace the original function with that in the limit. So now we don't need to worry about the value being undefined, so we can finally plug it in. After plugging it in, we get 3 squared plus 3 times 3 plus 9 equals to 27, which is our final answer. Consider the problem here. We have the limit as x goes to 0 of 1 minus the square root of 1 plus x all over x. Similar to the previous problem, we can't plug in for x, or else our answer would be undefined. It's also very important to notice that there is a square root here. This is a dead giveaway to multiply by the conjugate, which is our next technique. Multiplying by the conjugate is like the opposite of difference of squares, so it will help us get rid of some of the confusion in this function. So now let's simplify. It's also important to rewrite LIM and what x is going to, just because that's a proper notation. So now the function begins to simplify. We can see that the 1 and the 1 cancel out because of the negative sign in between. That leaves us with a negative x in the numerator, which cancels out with the x in the denominator, leaving us with a negative 1 all over 1 plus square root of 1 plus x. So now we can plug it in without worrying that the denominator will equal to 0. Since we've plugged it in, we don't need to rewrite the LIM and x goes to 0. The final answer is negative 1/2, and we got to this answer by multiplying by the conjugate. This method will help us simplify the function so it's easier to evaluate the limit. So this method is to get rid of fractions. Consider this problem. We have the limit as x goes to 0, and the function is 1 over x plus 3 minus 1/3, and that's all over x. Here we can see that there's fractions inside fractions, so the best policy is to get rid of the inner fractions. So now we can multiply by x plus 3 to get rid of the fraction that has x plus 3 in the denominator, and then we can also multiply by 3 to get rid of the 1/3. And anything we do to the numerator, we must do to the denominator. So all of this ends up equaling the limit as x goes to 0. The function is 3 minus x plus 3, and the denominator is 3x times x plus 3. Similar to the previous problem, now terms begin to cancel out. The 3 and the 3 cancel out because 3 minus 3 is 0. This leaves us with a negative x in the numerator, but that cancels out with the x in the denominator, leaving us with a negative 1 in the numerator. And that's negative 1 all over 3 times x plus 3. So now we can finally plug it in. So after plugging it in, we have negative 1 all over 3 times 3, which is negative 1/9, our final answer. The next way to evaluate limits is to simplify any trig you may find in the function. So let's take a look at this problem. We have the limit as x goes to pi over 2, cosine of x all over cotangent of x. We can rewrite the function to make it simpler. We know that cotangent of x equals to cosine of x over sine of x. So the function part of the limit becomes cosine of x divided by cosine of x over sine of x. So to make this simpler to solve, I rewrote the function as cosine of x times the reciprocal of cotangent of x. So that becomes sine of x over cosine of x. So here the cosine in the numerator and the cosine in the denominator cancel each other out, and we are left with the limit as x goes to pi over 2 of sine of x. So now we can plug it in, and we know that sine of pi over 2 is equal to 1. And that is our final answer. So the final technique involves horizontal asymptotes. So we'll have to recall some of the information that we learned from algebra and pre-calc. Let m equal to the degree of the numerator. As a refresher, the degree is the value of the largest power. And let's let n equal to the degree of the denominator. If m is less than n, then the horizontal asymptote is equal to 0. In other words, the limit as the function approaches infinity is equal to 0. If m is greater than n, then the horizontal asymptote does not exist, so we cannot utilize this method. Finally, if m is equal to n, then the horizontal asymptote is equal to the coefficient of the largest degree of the numerator divided by the coefficient of the largest degree of the denominator. I suggest you pause the video at this point and soak in this information. An important caveat of this method is that it only works if x is approaching infinity. Let's do 2 example problems. The first one is the limit as x goes to infinity, and the function is x squared minus 4x plus 3 all over x squared minus 1. Here we can see that the degree of the numerator and the degree of the denominator are both 2, so they're equivalent. So we should divide their coefficients. So 1 divided by 1 is equal to 1, therefore 1 is our final answer. The next problem is the limit as x goes to infinity, and the function is x minus 5 all over x squared plus 3x plus 1. So here the degree of the numerator is smaller than the degree of the denominator, so we know that the limit is equal to 0. Thank you so much for watching this video. I hope it was helpful. If you have any questions, please leave them in the comments section.